In the previous video, we discussed about functions, correct? We discussed about different types, that is one-to-one, onto, and bijective. Now, quick recap as to whatever we did. Whenever you talk about one-to-one or an injective function, for every element in the domain, we need to have a unique image in the range, isn't it? So, in the sense here, if you have this is domain and if this is range, every element of the domain should have a unique element in the range. This is what we call as one-to-one. So this is basically one-to-one, or you can also call it as an injective function. Now, when you talk about onto or surjective function, again you have two lists, that is two sets, you can say, more than the list. You have domain and range. Every element of range need to have at least one element in the domain. All right. So this is basically what we call as the surjective, or you can also call it as onto, like the one what we have here. See, if you have, say, 1, 2, 3, A, B, C, D. Now, each and every element must have, each and every element of the range must and should have a pre-image. Now, every element in the range, we call it as an image, and every element in the domain is what we call as a pre-image. All right. Now, if you have a function, so here remember this is onto. Suppose if you have a function which is both one-to-one as well as onto, we call that as a bijective function. So injective, surjective, and bijective. Correct? This is what we were discussing about in the previous video. Now let's take an example and check whether it is injective, surjective, bijective, whatever type. All right. The example what we have is a function f is defined from R to R. So when I say R to R, it's not range to range. It is set of real numbers to set of real numbers. All right. That is, domain is also real number, set of real numbers. Range is also set of real numbers. F such that it is from R to R and it is defined by f of x is equal to x square. Now we need to check whether it is bijective, or check for onto, one-to-one, and bijective. See, bijective comes only when it is both one-to-one and onto. Correct? So first we need to start from one-to-one and onto. Now when we have f of x is equal to x square, so first we'll check for injective, or you can also call it as one-to-one. Now for one-to-one, how we need to prove for one-to-one? All right, it's very important, because I can't always say that, oh, you know what, this is the set of domain, elements in domain, this is the set in range, I have image. You can't write that pictorial form every time. So what we do is that for one-to-one, if f of x1 is equal to f of x2, then x1 is equal to x2. Then we say that, okay, yeah, so we do have one injective part. All right. Now in this case, what do we have? See, f of x1 becomes x1 square is equal to x2 square. Correct? Or if you take it, x1 is equal to plus or minus x2, because when you take root. Now what do we have? We have two cases here. x1 is equal to x2 and x1 is equal to minus x2. You can't have both values. See, this is the whole point of telling you that it is not one-to-one, isn't it? So what do we have? x1 is equal to x2 and x1 is equal to minus x2. Since we have two values, we can say that, so this implies that f, or f of x, is not one-to-one. F of x is not one-to-one. Understood? So if it is not one-to-one, then it can never be bijective. We'll write that part later on. Now we'll go for onto now. All right. See, what is your function? So this is for onto, or we can also call it as the surjective part, right? So for onto, we have y is equal to f of x, which is equal to x square. Now remember, range is set of all real numbers. So when you have range to be the set of all real numbers, we can say, see, y belongs to R. Suppose if y is less than 0, any value less than 0. So what do we have? Y is equal to x square. In other words, x square is less than 0. Is it possible for a square number to be negative? It is possible only if you have complex number. But here we are talking about set of real numbers, isn't it? So what do we get from here? For all y less than 0, comma, comma, x value does not belong to domain. Or you can also call it as x value does not belong to set of real numbers, isn't it? My domain is nothing but real numbers, set of all real numbers. So what do we say from this one? Therefore, or this implies that f or f of x is not onto, or you can also say it is not surjective. Got it? So what can we say at the end? That f of x is not bijective. Understood? So this is how you solve a problem. Okay, this is how you solve. This was an example. See, from the next video onwards, we'll start solving problems on these things. Whether it is surjective, injective, bijective, there are certain typical problems what can be asked in your exams. Those problems and other problems too. So we'll solve these in the next video.